Have you ever wondered how the world might end? If you're a fan of Hollywood disaster movies, you've probably seen depictions of asteroids crashing into Earth or aliens arriving to annihilate humanity. But while these scenarios are dramatic, scientists have warned about a real cosmic threat that could actually wipe out life as we know it, the kilonova. In this video, we'll break down what a kilonova is, why it poses such a catastrophic risk to our planet, and how likely we are to encounter one in our lifetime. Spoiler alert, the chances are extremely slim. But the potential consequences are so severe, it's still worth understanding this mysterious cosmic phenomenon. We've got a lot to cover, so let's get started. First up, what exactly causes a kilonova explosion in the first place? A kilonova is an immense stellar explosion that occurs when two neutron stars collide and merge together. Neutron stars are some of the smallest yet densest objects in the universe, packing an incredible amount of mass into a relatively tiny space. When two of these ultra-dense neutron stars spiral towards each other and finally collide, it unleashes a massive burst of energy. This creates a fireball of radioactive debris expanding outwards at very high speeds. The initial collision lasts just a few seconds, but it releases more energy than the sun will radiate in its entire lifetime. It creates a blast over 1,000 times brighter than a classical nova explosion. As the debris expands outwards, it creates a luminous flash of radioactive light. This light is special because it contains high concentrations of heavy elements like silver, gold, uranium, and platinum. Scientists are fascinated by kilonovas because they act like cosmic forges, manufacturing heavy elements that get dispersed throughout the universe. But as we'll discuss next, these powerful explosions could also spell disaster for life on Earth if one happened to occur too close to home. According to a new study by scientists at the University of Illinois Urbana-Champaign, if a kilonova occurred within around 36 light-years of Earth, the resulting radiation could cause an extinction-level event. Yikes! But before you start panicking, it's important to understand the chances of this happening are extremely low. The nearest known neutron stars are more than 400 light-years away, well outside the danger zone. So why exactly could a kilonova 36 light-years away wipe us out? The main risk is from the flood of powerful gamma radiation it releases. Gamma rays carry so much energy, they can ionize atoms by stripping their electrons away. If these rays reached Earth, they would decimate our protective ozone layer. This exposes us to harmful UV radiation from the sun that could trigger mass extinction. The effects could persist for thousands of years until the ozone layer gradually reformed. There are a few uncertain variables that determine the exact distance a kilonova would need to be from Earth before it becomes an extinction threat. These include the total energy of the blast, how the debris is ejected, and the viewing angle from Earth. But based on their parameters, the researchers concluded the gamma ray exposure would be the most damaging factor. Other threats like cosmic rays from the jets of matter ejected would require a different hit to affect us from hundreds of light-years away. So, in summary, getting zapped by a nearby kilonova could indeed wipe out most life on Earth. But we shouldn't lose sleep over this, since the odds are so extremely low of one happening close enough to threaten us. If kilonovas are so potentially devastating, why don't we know more about them? Well, the fact is these elusive explosions are incredibly difficult to detect and analyze. The reason is twofold. First, they are extremely rare occurrences. Neutron star mergers are estimated to only happen around once every 100,000 years in a galaxy the size of the Milky Way. With hundreds of billions of galaxies in the observable universe, that's still a lot of mergers, but in cosmic terms, they are uncommon. Second, the explosions themselves last just a few seconds before fading away. This fleeting duration gives astronomers a very narrow window to observe them. In fact, the first kilonova ever detected was only in 2017, when the LIGO and Virgo gravitational wave detectors picked up ripples caused by two neutron stars merging. This collision, located 130 million light-years away in a galaxy called NGC 4993, is the only kilonova we've been able to study across the electromagnetic spectrum so far. Prior to this, scientists had theorized that neutron star mergers could create heavy elements through rapid neutron capture, but we didn't have direct observational evidence to prove this until recently. Just this month, researchers were able to analyze the aftermath of this merger using the new James Webb Space Telescope. For the first time, they identified tellurium in the kilonova spectra, confirming these events synthesize heavier elements. The observations also revealed new insights about the extreme physics and expansion rate of the debris, but there is still so much we hope to uncover with future kilonova detections. The more we can observe, the better we can model their potential effects. While the chances of one ever threatening Earth are basically zero, expanding our knowledge helps us prepare for even the most obscure cosmic scenarios. And with that cosmic perspective in mind, we've reached the end of our deep dive into kilonovas, one of the most violent and mysterious phenomena in our universe. To recap, these immensely powerful explosions occur when two neutron stars collide at incredible speeds. The initial burst lasts just seconds, but releases astonishing amounts of energy. This expanding fireball forges heavier elements and generates high-energy electromagnetic radiation, including dangerous gamma rays. If a kilonova occurred close enough, these rays could deplete Earth's protective ozone layer and expose us to lethal UV radiation. So, in a very unlikely scenario, a nearby kilonova could threaten life on our planet. But the odds of one happening within the hazardous range are extremely minimal. The closest known neutron stars are hundreds of light years away. And despite the potential risks, it's important to study these rare cosmic events. With better observations and models, we can unravel the mysteries of kilonovas to gain insights into physics, astronomy, and the origins of heavy elements like gold and uranium. The more we can observe, the better we can prepare for even obscure cosmic scenarios. But there's no reason to lose sleep over the threat of a nearby kilonova ending life on Earth. The chances are astronomically low. Lastly, today we explore the intense science behind kilonovas, some of the most violent cosmic explosions in our universe. These rare and mysterious phenomena occur when two neutron stars collide at incredible speeds. For just a few fleeting seconds, these dramatic mergers release immense amounts of energy and forge heavy elements like gold, uranium, and platinum. The initial burst creates a fireball that generates high-energy gamma radiation as it expands rapidly outwards. If a kilonova occurred within around 36 light-years of Earth, scientists warned the gamma rays could deplete our protective ozone layer. This would expose us to harmful UV radiation from the sun that could trigger a mass extinction event. However, the likelihood of a kilonova happening close enough to threaten us is extremely tiny. The nearest known neutron stars are hundreds of light-years away. Besides the slim chance of danger to Earth, kilonovas have been difficult for astronomers to study in depth. Their rarity, only happening every 100,000 years per galaxy, gives few opportunities to witness them. And the explosions themselves vanish within seconds, leaving a brief window for observation. It was only in 2017 that scientists spotted the first kilonova in both electromagnetic radiation and gravitational waves. New insights are still emerging as we analyze the data from this collision 130 million light-years away. The more we can observe these brief yet energetic explosions, the better we can unravel their mysteries. Kilonovas provide crucial insights into physics, astronomy, and the cosmic origins of heavy elements. While an Earth-threatening kilonova is improbable, expanding our knowledge helps us prepare even for obscure scenarios. By demystifying these extreme events, we gain a deeper appreciation of the wonders and risks across our dynamic universe. Well, that's all for today. Let us know in the comments if you want us to cover any other mind-blowing cosmic mysteries. And don't forget to like, subscribe, and click the bell to join us on the journey to demystifying our incredible universe.